Hey guys, in this video, I want to talk about factoring. Um, First, I'm going to introduce the general strategy for factoring, but then I'm going to go over specifics for different types of polynomials. So we're factoring polynomials, and your first step is always to check if there are common factors in all of the terms, called the GCF, the greatest common factor. And if there is, then you should factor it out. So that's your first step. After that, your goal is to identify what kind of polynomial you're looking at, because your strategy for factoring will depend on largely on that. So we have different, I want to be you to understand this. We have different techniques for factoring different types of polynomials. So if there is a two-term polynomial, then it could be a difference of squares, a sum of squares, difference of cubes, and or sum of cubes. And we have formulas for each one of them, except the sum of squares is a prime, not factorable. Now, not all two-term polynomials will fit these patterns. Some will not. If they're not factorable. Only those that fit, only those two-term polynomials that fit these patterns will be factorable, and it's up to you to check if they are the type that's factorable. Now, next one up is a three-term polynomial, and again, they're telling you three different things about the three-term polynomial, but don't worry about that. We're gonna use one technique for three-term polynomial, which works for any case, and you don't have to worry about all of those other cases. And there is also a four-term polynomial, which is typically factored by grouping. Remember to always factor completely and double check if anything else could be factored even further. And check your work by multiplying the factors. So that's the general strategy. Now let's go to specifics. So here we're looking at a polynomial, and if you count the terms, there's three terms, but the first thing that we need to check for is a common factor. And most people can just look at the terms and say, okay, yes, they have um, the x term, each one has an x term, each one has a y term. So at least they have xy in common. And then when you look at 6, 45, and 21, they all have 3 in common. So you would pull out 3, and you would pull out x to the least degree, which is 1, and y to the least degree, which is y. Okay, so first let's actually, but if you are not one of those people who could just look at it and see what's going on, then you could try prime factorization. Just basically um, decompose every term down to prime factors. And I'm going to show you how to do that. So 6x cubed and y cubed is, well, 6 decomposed will be 2 times 3. And then you have 3 factors of x. That's what x cubed mean. And then you have 3 factors of y for this term. The next term, 45, well, I'm going to do this on the side, how to decompose 45. So 45, when I look at it immediately, I think, okay, it has factors of 5 and 9. And that is correct, but 9 could be decomposed even more. We could split it into 3 times 3. right? So your prime factors for 45 would be 5, 3, and 3. And that's what I will write here. So 5, 3, and 3. And what do we have? We have 2 factors of x and 2 factors of y. Now for 21, that's that's going to be 3 times 7. Both of these are primes, cannot be broken down anymore. So that's it. Now, when you look at all of these factors decomposed, all of these terms decomposed, what do you see that they share? Well, every one of them has a 3, and every one of them has an x, and every one of them has a y. Okay, good. So we found our common factor, and we're gonna write it out. So 3xy for all of them. Now the question is, what do we have left? Well, we have from the first one, 6x cubed y cubed, we have 2 and an x and an x and 2 y's. Okay. Now for the second one, we have 5 left, another 3, another x. And why did I circle 2 y's? I don't know, but it's only one that we pulled out, so I'm going to have one more here. And here, what do I have left? Only 7. All right, so now we can write these guys in a shorthand term. So this would be 2x squared y squared, and well, this would be 15xy, and this is just 7. So when we pull the finally, when we pull the common factor out, that we agreed that was 3xy, you open parenthesis, what do you have left from 6x cubed y cubed? Well, that's 2x squared y squared. And from 45x squared y squared, we have 15xy. And from 21xy, we have only 7 left. And that will be your final answer. Oops. All right. So that's your final answer. Okay, so that would be your first step in factoring polynomials, always. Now I want you to try it yourself and factor out the GCF out of this expression. Pause the video and ask me any questions if you get in trouble. All right, so another type of factoring GCF is when your common factor is not just a multiple, a simple factor like x or y or 3, but it is a group. Like in this case, we have b squared minus a is multiplied into x the first time, and the second time it's multiplied into 6. And it is a common factor for both of them. Well, what do you do? Well, you approach it the same way that you approached the previous one, uh, treating this as a factor, just one, as if it was an x. So if it was just x or y, because we already have x here, what would you do? Well, and let's actually write it as a y. So we have xy plus 6y. So what do you do? Well, you pull the y out, right? and you're left with x from the first term and 6 from the second term. That's how you would do it if it was a simple y, right? So here for the group, it's the same principle. It's the same exact thing. What you do is, I'm gonna rewrite it. So I have x b squared minus a plus 6 multiplied by b squared minus a. So what I do, I just pull b squared minus a to the front, and what do I have left? Well, I have x left from the first term, and I have 6 left from the second term, and that's how it works. Another twist on this type of factoring, so to speak, is when your common portion actually has exponents on it, and fractional exponents sometimes, um, sometimes even negative rational exponents. So what do you do then? Well, it always, and I mean always, factor out the factor to the least power. Factor out the least power. So that's our strategy. Okay, so just, before we begin, I want to remind you that when we actually factor something out, the power of that factor is reduced in whatever's left over. So here we used to have 6x cubed y cubed. Now, when we pulled out 3xy, we have 2x squared y squared. So the power went down. Now, it went down how much? Exactly, how many factors of x we pulled out. So by 1. And here, the power on y is reduced by 1. So um, this this 2, it used to be 3 minus the one that we pulled out. So this is a very important concept that we're going to use here for this problem. Let's do it. So what are we pulling out? We're pulling out x plus 2 to the power negative 1/3, because this power is smaller than the power of 2/3. Okay, so let's see, what do we have left? Well, first of all, we have 3x left, right? And now this term is exactly the same as here, so it's gone. We don't have it anymore. Now, what do we have here? 4, obviously. And then what do we have left from this term? Well, let's talk about it. So we had x plus 2 to the power 2/3, correct? But then we pulled out the power of negative 1/3, so we have to subtract it from this exponent. So we're subtracting a negative term, a negative fraction, so this is going to be plus eventually, right? So we have x plus 2 to the negative 1/3, so I'm copying it. 3x plus 4, and x plus 2, what happens to the power? We have 2/3 plus 1/3. Well, that's a full 1, correct? So it becomes 1. So now we have 3x plus 4 is x plus 2 to power 1. So I'm not going to write the power 1. It's by default. Now what we need to do, we need to simplify this right here. I'm going to distribute 4 and combine like terms. and this x plus 2 to the negative 1/3 power is here. Doesn't go anywhere. Okay. Um, so combining 3x and 4x, we have 7x plus 8, and this is it. This is your final factored form. Now I want you to try it yourself. And you're going to try 2 times 5a minus 1 to the power 3/4 plus 7a times 5a minus 1 to the power negative 1/4. So go ahead and try it. Pause the video and see if you can get it. All right, so past the factoring out the greatest common factor. We mentioned in that handout that you're gonna count the number of terms and decide which technique to use. Well, we're gonna start with 4, not one number of terms 4, and you already looked and saw that there are no common factors in all 4 of those terms. Then time comes to factor by grouping. And what that means is that you're going to group the terms that have something in common together in groups of 2. So you're going to match them up. And if you look at 3a squared and b to the 5th or to the 3rd, they don't have anything in common, right? So you would not group 3a squared with b cubed. And if this this polynomial would be arranged that way, let's say you had 3a squared minus b cubed plus ab squared minus 3ab, you would not group this the first term and the second term in that case together because they don't have anything in common. You only group the terms that have something in common, and sometimes that means that you need to rearrange them. Now, in our case, they're already arranged so that the first 2 terms, they have a in common, and the second 2 terms have a b in common and a negative. Guys, -1 is a common factor here. Don't forget about that. So we look at 2 terms separately, into those 2 groups separately, and pull out the greatest common factor. Well, for the first group, it is a. So we pull out a. What do we have left? We have 3 and another a, and we have b squared from the second factor. Now, from the second group, we're pulling out a negative, and we're pulling out a b. What do we have left? Well, from the first term, we have 3 left and an a. And from the second term, we don't have negative anymore. We pulled it out, so that's a plus. And then b squared. Okay, but now look at that. We got our common term, which is a group. And what do? Same thing we did before. We pull it out, 3a plus b squared. And inside, well, we have a left from the first term and negative b left from the second term. And voila, this is your final result. And again, I do want you to try it by yourself. And what I want you to try is this polynomial, 2x squared plus 2ax plus 5x plus 5a. Again, pause the video, try factoring it, and see what you come up with. Let me know if you have any problems. Okay, so the next type of the polynomial that you may be looking at is factoring trinomial by grouping. Okay, and this is the only technique, the technique that I show you right now is going to be the only technique that you need. Like if you will factor it if your A is 1, that's one of the types that they had listed on that handout. Or if this is a perfect square trinomial, this technique will work for all of them. So please learn this technique because, and that's the only technique that I want you to remember, because with other techniques, a lot of times students get confused and they get stuck into those techniques. And when they get something like this, they don't know how to factor it. Okay, so, well, this technique is called magic X. Basically, what we're looking for two factors, two numbers. We're going to call them P and Q, such that if um, if you multiply them, you get a product of the first coefficient and the second and the last coefficient in this trinomial. By the way, I didn't mention it, but we should talk about the fact that your trinomial has to be written in this form. So your highest term, your squared term first, then your x to the power of 1, and then the free term. This is called a standard form. So it has to be written before we even begin to talk about it, it has to be written in this form. And this is the form ax squared for plus bx plus c. That's how it's written in general. So in our case, a is 5, b is 7, c is -6. All right. So any trinomial that looks like this, and you could stick in any other numbers for a, b, and c, that would be this type of trinomial. This is called a quadratic trinomial. So that's a little bit of background on it. So whenever you have a quadratic trinomial, when you multiply your first coefficient and your last coefficient, your a and c, a times c. In our case, let's apply it to our case. That's 5 times a -6. Don't forget that negative. C is a -6, which gives you -30. Okay, so we're going to be looking for two numbers, P and Q, and they have to multiply to -30. And I know some of you say, okay, yes, it's 5 and -6. True, but not so fast. Okay, they also have to add to the middle coefficient b. Okay, in our case, it's so while it is true 5 and -6 when multiplied will give you -30, but when you add them, they're not gonna give you 7. So that's why we have to look for different two numbers, p and q. Okay, and if this trinomial is factorable, there will be only one pair of numbers that fit that description. Okay. And to make this a little bit, the search a little bit easier, what we do, we make this x and we write the -30 here. That's our product for P and Q, and 7 down there. That's our sum for P and Q. And yes, we're trying to guess two numbers that will multiply to -30 and add to 7. And you could go through factors of -30. How can you split 30? So 5 and -6 is just one way. -5 and +6 is another way. 2 and 15 is another way, or -2 rather, and 15 is another way. And what are the other ways to split it? Well, if you look at it long enough, you'll realize that 10 and 3 are the other ways to get 30. But to get -30, one of them has to be negative, right? And if 10 is negative and 3 is positive, that will give us -30, but it will give us -7, not a +7. Only +10 and -3 will give us what we need. We need -30 when we multiply them and +7 when we add them. And here we go. We got them, those numbers. Okay, so once we have those numbers, what do we do with them? And no, those are not the factors. A lot of people um, jumped straight to factoring. You cannot do that yet. You would be able to do that if instead of 5 you had 1 here, then that works. But if you don't have a 1 here, then it doesn't work, and you have to do something else. So what you're gonna do, we're gonna copy this polynomial. I'm gonna copy it here. So we have 5x squared plus 7x minus 6. Okay, so what I'm gonna do now, I'm gonna split my middle term using those numbers that I just found. So instead of 7x, I'm gonna have 10x and -3x. So that's how I substitute 7x basically with 10x and -3x. And I'm gonna copy down the other terms. Okay, I'm gonna copy them down. So now I have a polynomial in 4 terms. And what do? We just proceed as before. We treat it as a polynomial in 4 terms. We're gonna factor it by grouping. So I'm gonna group these two together, and they have a common term, 5x. So x plus 2. And then I'm also gonna group these two together. And what do they have in common? -2. So I'm gonna pull out -2 and -3. I'm sorry, I'm very tired right now. So I was like, it doesn't come out. Now it does. All right, so we have a common factor now, x minus 2, or a common group factor. So we're gonna pull it out, and what do we have left? Well, from the first one, we have 5x. And from the second one, we have -3. And that's it. That's your factored form. And yes, I do want you to try it by yourself. So yeah, the one that I want you to try is 2x squared plus 9x plus 9. Try and factor this one. Pause the video here. And we're going down in the number of terms. And now we're going to talk about polynomial when you have 2 terms. There's only 3 types, 2 types really polynomials with two terms that we can factor, and they have to fit a certain patterns. Okay, so and the patterns are, they could be a difference of squares, a squared minus b squared, or like if you identify that there's sum of squares, that's not factorable. But it's prime. But you could also have a difference of cubes, or a sum of cubes, and both of those are factorable. Okay, so how do you identify it? Like, you look at each term and ask yourself, is this a perfect square, or is this a perfect cube? And if both of them are perfect squares, or both of them are perfect cubes, then you're gonna say, yes, I can factor it using one of the formulas. What are the formulas? Let's see. Okay, here they are. They're in your handout. By the way, the handout is posted to course Canvas. And here are the formulas. So if you have a difference of squares, a squared minus b squared, then it's factored into a minus b multiplied by a plus b. Now, if you have a sum of squares, the polynomial cannot be factored, it's prime, just like we mentioned. If it's a difference of cubes, it's gonna follow this formula for the difference of cubes formula. And if it's a sum of cubes, it's gonna follow the sum of cubes formula. Okay, which this formulas, I'm sorry guys, but you do have to memorize them. Okay, so let's take a look at our polynomial at hand. Well, I see that 9x squared is a perfect square, and it's 3x squared. I also see that 25 is a perfect square, and it is 5 squared. Okay, so I'm going to follow the difference of squares formula, which again, if you don't remember, it's a plus b times a minus b. So in this case, my a is 3x and my b is 5. So that's going to be 3x plus 5 times 3x minus 5. Okay, and that's it. That's how you factor that. And yes, which one do I want you to try? You're going to try 81x squared minus 100. So that's the one that I want you to try. So pause here and try it. All right, so I hope that you already did that one. And the next one up is x cubed plus 512. And I tried 512 to see, like, if you look at my calculator, I tried different. So I tried different cubes to see which one 512 was, and I found that 512 is actually 8 cubed. So it is a perfect cube, and my x cube is also a perfect cube. It's x cubed, and 512 is 8 cubed. All right, so I know I have sum of cubes, right? So what's the formula? It's a cubed plus b cubed. And this is called a subformula. I'll tell you why in a second. So the first factor is just a plus b with no cubes. So you just repeat what you have here without cubes. That's same. And then you have a squared minus ab plus b squared. So it's, the rest is kind of like a quadratic formula, difference of quadratics, but without the 2 in for the middle term. So that's how I remember it. It's called the SOAP formula because SOAP refers, it's an acronym that refers to the signs. So the first sign is the same as in the original expression. This one is opposite. Okay, and this one is always positive. So hence the SOAP. All right. Okay, so once you remember that, you don't have to memorize the difference of cubes separately. It follows the same pattern, just this, as long as you know which signs to use. So for the difference of cubes, it's the same. Oh, minus. And then a squared, the opposite, which is plus, maybe. And then the last one is always positive, b squared. So same pattern, the signs, just use your SOAP to remember the signs. Okay, so with that out of the way, what do we have? Well, um, same, opposite, x times 8 or 8x, and always positive, 8 squared. So the only thing that we need to do now is to actually square the 8, and we get x plus 8, x squared negative 8x plus 64. And I know some people look at it and say, okay, this is a trinomial. I probably can factor it. And I save you some time here and say don't try it, because it's usually, when it comes from this formula, from these types of formulas, they are primes and they cannot be factored anymore. So if you factored a sum of cubes or difference of cubes, and you got a binomial and a trinomial, stop here. Don't try to factor the trinomial. It's not factorable. Okay, so one other type of difference of cubes that I want to show you is this. A lot of times students have no problems seeing that this is a cube, right? This is a 10x cubed. But then when they look at one and say, no, it's not a cube, so I can't do anything. But I want to tell you right now, one is a perfect cube. One is 1 cubed. It's also a perfect square. It's also a perfect 1 to the 4th power. It's the perfect any power. Okay, you could treat it as cube, you could treat it as square, you could treat it as any power. So don't miss it, okay, when you see it. All right, so how does it factor? Well, we're gonna follow our pattern here. So 10x minus 1 is the first factor, and the second factor, I'm going to square it. It's 100x squared, and then the sign is opposite. 1 times 10x, and always positive. 1 squared, which is a 1. Okay, we're done. And again, which one do I want you to try? I want you to try 216a cubed plus b cubed. And this is it for factoring strategies. So let's sum up. The first thing that you will try is to look for the least common least common denominator, else else no, not LCD. The greatest common factor is what it is. Okay. I'm tired. Anyway, so first is we're looking for the greatest common factor. The second step is to count the number of terms in your polynomial and apply the approach that's applicable to your polynomial, depending on the number of terms. If it's 4 terms, you're factoring by grouping. If it's a trinomial, then you do the magic X. If it's a binomial, then you're looking for perfect cubes, perfect squares, and apply the corresponding formula. That's it, guys. I'll see you in the next video.